see here, we're pumping in data. I kind of just chose, ones and zeros arbitrarily, and it interpreted it.
It's just random.
Yeah, it's just random. Nothing worth seeing. But as you can see here, we're stuffing data into the buffer until it's full, and then as soon as it's full, the read enable signal goes high, so that we're reading out data and we're shifting it into the cipher in register. And so we're shifting all this data in basically until the FIFO is empty. And this D out is all the data that's being shifted. So you guys can't really see it, but it follows this sequentially, 67 CE, 65 CC, 67 all the way back. And so all the right data is presented to the cipher, but for some reason it's just not perplexed.
So this is the XT decryption module. Basically, we have two 32-bit lines for going into the cipher. For this example, for the first line, 1, 2, 3, 4, 5, 6, 7, 8, 32-bit hex, and then A, B, C, D, E, F, E, B. Then the data gets encrypted here using a 128-bit key that we just generated. It's hard-coded into the cipher, into the hardware. But and this is what the encryption. Yeah, this is the encryption.
No, this is the other way.
Oh, this is the other way around?
Yeah, this is.
Oh, okay. Sorry,
this is the decrypting this data.
Sorry. I can't read that.
Yeah, in the report we go through matching slides where we just encrypt it and then decrypt that same data. A little proof of concept. And it's interesting because we initially took that XT Cipher core from OpenCores and wanted to implement that, but the core that we downloaded didn't work. So we will be submitting a revision to that core since we got it working. It was just some minor changes.
So anyhow, what we're going to demo right now, since it stops the data when it gets to the cipher, we're just going to demo the UART controller and the pass-through of data from hyperterminal to the UART and then back again to hyperterminal.
So what this is now is, initially we were going to have a switch to say, bypass the XT cipher. Okay, so that's what this is. These LEDs here, one of them is this one here is just used to show that the UART.
Can you touch the screen?
Yeah.
Save it.
Yeah. This one here is just showing the UART clocks on. This last one here is the empty signal. So right now there's nothing in the buffer. And so this is what's coming out of the transmit UART on our device. Oh yeah, and for this example, that's only a 4x4 FIFO. Yeah. So we're going to pass in 4 bytes before it spits anything out.
4 data, 4 letters.
Yeah, four ASCII letters. So
I'm going to hit.
And each one is 8 bit.
Yeah. So he's hitting
I'm going to hit A, S, D, F. Nothing.
And so it starts printing
Pass the SDF.
at the 4th.
Yeah.
Okay.
And then I'm going to hit G, H, J, K.
So it starts printing out everything that's stored in the FIFO.
That's stored in the FIFO, yeah. Then I'll hit Q, W, E, R, T, and you'll see as it'll start coming.
And then here we can clear the FIFO and start it all over. Like
start A, S, D, F.
So it doesn't print any of the data that was originally stuck in the FIFO.
G, H, J, K, L. So you'll hit what? Okay.
So unfortunately we can't
demo the encryption.
Demo the encryption.
Except
so this is just discretion input.
Yeah, this is
And you type in ASDF.
Yeah, so
and it stores it in the FIFO, and then as it gets new data, it prints it back out
to the screen.
Yeah, it's basically the read enable and the full signal are tied together so that it only will transmit data when the FIFO is full.
So what you print out right now is the encryption version of the ASDF.
No, this isn't encrypted.
This is not encrypted.
This is not
No.
encryption. This is just demoing the UART controller itself, passing data
To the
control
faithful.
on the board.
Yeah, all this is right now is